One last call to come on in and take your seats. Okay, without any further ado, I'm going to hand it over to Dean Kamen for some introductory comments. Dean?
Thank you. I'm just looking for the node for the feedback, and I don't, there it is. So first of all, as always, I'll start by apologizing. A lot of good people worked really hard to make this a nice, organized event with a realistic agenda and a schedule. As usual, to live down to my reputation, I'm screwing it all up. What happened was, relatively recently, in the last few days, I realized that if we're going to get the whole New Hampshire High Tech Council, Mass Bio, all the people here to talk about something as big as ARMI, with as much of a focus as you're going to hear tonight on making the BioFab USA project within it a reality, which will take virtually all of you and a lot more people, I realized that we've got to get our secret weapon here. I happen to see our governor, who was here when we launched this thing, and by far, was the most energized speaker we had, and we had a lot of pretty impressive people here for the kickoff. He gets it, he's a techie, and I told him that we'd made a lot of progress, and that, if anything, I'm no longer worried. I am no longer worried that the vision of creating a whole new industry to create human organs is a reality. We've already, in the 1 year we've been at it, we've found enough technology people in all the various aspects of what it's going to take, and enough people in the medical industry to give it input and guidance, and we have senior people from the FDA that are now on our team, and you'll hear from some of them. So there's no question that relatively soon, in the grand scheme of a lifetime, you're going to start seeing regenerative medicine have a huge positive impact on healthcare. The question that becomes more and more unnerving to me is, as we've explained our vision and we've shown the path, are we going to be able to plant such deep roots to this thing and get such a critical mass around the creation of this new industry that it grows out of this million, out of this city, out of this state, as opposed to, why did Silicon Valley end up there? Why did the car industry end up where it is? And I think one of the things that it's going to take to make sure all the right ingredients to build that infrastructure, to build that ecosystem are in this state are things we've asked our governor to help us create, including some pretty neat programs for keeping people here, especially if they've had an education that's necessary to build this industry and they stay for 5 years. That's to prove to the very conservative folks here that they can't take our value somewhere else, Senator. But anyway, I said, Governor, I don't know how many times we're going to get a coalition of people that are interested in helping, but they need to hear from you. Well, Dean, I've got other commitments. There's not a lot of notice. Gee, Governor, that sounds like a personal problem. This is an important commitment. Anyway, seriously, we interrupted something he's got to do tonight, so he's going to have to be our first speaker, as opposed to I was hoping he would close it after you hear all the compelling things. And I apologize that we have pushed you a little off schedule. But I thought it would be worth it to us, and I hope to everybody that's come, you'd appreciate the actual huge bonus that we're going to start this event with an incredible supporter of ARMI and everything we've done up here, basically, but of BioFab USA, Governor Chris Sununu.
Thank you, man. All right, thank you. Thank you, guys. Here we go. Thank you. Oh, please, please. Well, that's always quite an introduction from Dean. Look, Dean has really been there for us. He really has. And he's been there for Manchester. He's been there for this industry. He's been there for this state. He's been there for engineers, as I am one. If you're an engineer, raise your hand. Oh, I love it. I love it. I'm talking to my own people. Look, this isn't just a promise. This isn't just an idea, right? We're talking about there's no one on the planet that is better at turning ideas into reality. Because for Dean Kamen, it's the same thing. It's absolutely the same thing, because he doesn't believe anything can get in the way of doing amazing things. And we're sitting in it. And people think it was a bunch of hype. People thought Dean Kamen was crazy when he went down to Washington and essentially outbid every other state, every other major institution in the country, didn't put a penny on the table, didn't have the state put a penny on the table at the time, and convinced the government that this is going to be the Silicon Valley of regenerative medicine. Because it is. Not because we hope it is, because it is. This is ground zero. This is it. How many are from New Hampshire? Okay, how many are not from New Hampshire? All right, I give you guys till about Monday till you guys change your mind. Look, let's look at the facts. And we're not just whistling Dixie. There is a reason New Hampshire has the fastest growing economy, the highest per capita income in the country, the fastest growing population in the Northeast. Take that, Charlie Baker. I remind Charlie all the time. The workforce is moving in. The economy is booming. 2.6% unemployment. All the fundamentals are there. Not because on accident, because we're doing if I can just say, we've been putting things in place. Not just over the last couple years or over the last year since I've been governor, but really over the past 200 years. No sales tax, no income tax. A government that works with you, not against you. And for all of you who are going to head back to Massachusetts tonight, or wherever the heck you're from, as you're sitting in traffic, and you're trying to figure out, who do I know that might be able to know someone in the office of someone that might be a representative to maybe get me a meeting somewhere down the line with the governor of Massachusetts. Good luck. It's not going to happen. Right? In New Hampshire, we're here. And we're not here because we prop ourselves up. We're here because we want to say, what do we have to do to make this happen? Tell me what we have to do. We have the most comprehensive regulatory reform ever comprised in the state sitting in the legislature right now. Because of Dean and ARMI, we're putting forth student loan repayment programs that nobody even thought possible a couple years ago. They're realities today. In the next couple weeks, we're going to announce a $100 million capital investment in partnership with the university system for the new research park. Very much in part with what is going on with ARMI. And then you had all the other manufacturers in New Hampshire. This is it, man. This is the place to be. And you're going to hear some great things. You're going to hear some really great things over the course of this symposium. In this room, I've been in this room a couple times, right? People keep coming back. The room keeps getting more and more filled. And again, for those of you who aren't from New Hampshire, at the end of the month, when you're writing that rent check for $1,500 per square foot, and you know you have to go explain to your board of directors and your shareholders why you're paying so much money, because you're thinking like it's 1985 and you have to be right next to MIT to get anything done. If it was 1985, I'd tell you you're right. You're talking to an MIT guy. But it's not. This is a completely new age. 2018 is where if you're in this industry, if you're in this room, you get it. This is where to be. We got the mill space, we got the technology, we got the partnerships. It's not an idea, it's not a hope, it is the absolute reality. And for those of you who decide to move here on Monday, you're already a little bit late, but that's okay. We will make space for you. Look, we believe in our entrepreneurs, we believe in our business leaders, we believe in those who believe in themselves to make things happen. When you come to visit the government, it's what can I do to get out of your way? Right? What can I do to possibly lower taxes more? People thought we couldn't get any lower in taxes. Guess what? I lowered business taxes last year too. And we'll do it again. And we'll do it again. And we'll create opportunities. Government is not here to guarantee much. I say that all the time. Maybe very different than what other governors say. I'm here to guarantee you a job. I'm going to guarantee this. No, I'm not here to guarantee you anything except opportunity. The opportunity for you to succeed, your business to succeed, your family to succeed. And that's why we're so successful here. I'm not just up here, I don't want to be up here just being a billboard for a state of New Hampshire. You know what? The state sells itself. Live free or die. It's not just 4 words on a license plate. It is not 4 words on a license plate. It's how we do things here, right? And we do it with a positive energy. We don't let all the negativity of whatever the heck is going on outside the 603 drag us down. We're just constantly banging down doors, seeing what we can do to make it happen for you guys. If you're here, you get it. The homework assignment, go find 10 more people, right? Go bring them up here. Show them what is going on up here. It is like nothing they've ever seen before. It's access to government, local control, personal control, allowing a system that allows you to make your destiny. That's what Dean did. He saw a license plate one day in, was it Brooklyn? I don't know, he's down in New York. Saw a license plate. Live free or die? Damn, that's the place I gotta be. Amazing things happen. In less than a year, he's allowed $250 million of investment to come right into this building right here. Imagine what will happen in the next 3 years. And if you're outside this building, if you're down in Massachusetts and Connecticut, looking north, going, why didn't I decide to get up there and be a part of that earlier? We'll still take you, but now's the time. Now's the time to make the investment. I got folks from Hong Kong going to be sitting in my office next Friday. They said, we don't know much, but we know we want to invest in regenerative medicine, and we were told to come to New Hampshire. That's the God's honest truth. And this gentleman, Mr. Wong, is going to be sitting in my office. And there's some folks from ARMI going to be there with me. And then he's going to come down here, and we're going to try to get him a tour. And that's what's happening. We are on the cutting edge of amazing things here. Amazing things. Thanks to this guy. And thanks to a lot of other people in this room. It's team effort. Build a great team, empower them, let them do great things. Thank you guys very much. Thank you, Dean, for keep doing awesome things. Let us know what we can do. We're here for you. Thank you, guys. I don't know. How's that right, man?
Thank you. Now you know why I figured it would be worth taking the heat to interrupt what was going to be a nice little program to have our secret weapon give his sense of the priority and importance of what we're doing. I will now return to our regularly scheduled program. I will now ask Toril to come on up and return us to what I think you all thought you were coming to hear about. And I really do want to thank you for being so flexible. As the chairman of the New Hampshire High Tech Council and all the other sponsors, I appreciate letting us give the governor the opportunity to share his vision. And again, I hope you see that this is going to be very real. So, Toril.
Can you hear me now? So not just one hard act to follow, but two hard acts to follow. Lucky me. Welcome to the New Hampshire High Tech Council Biotech MedTech event. As Dean mentioned, my name is Terrell Cowieson, and I'm the council board chair, where I have the privilege of working with some amazing business leaders in our state, many who are in this room tonight. I'm really excited to be here with all of you, particularly in this space and this building with so much history and so much possibility. Tonight, obviously, we have a very special opportunity to learn more about the regional impact and activities of the Advanced Regenerative Manufacturing Institute and BioFab USA. I'd like to start with some acknowledgments because it truly takes a community to make all of this happen. Thank you to ARMI and the leadership team for providing the space and being our host sponsor. Thank you also to our other sponsors who are noted on the screen: Bernstein Schur, Thermo Fisher Scientific, B&V Testing, Sunrise Labs, Superior Controls, and Biogen, and our promotional partners, MassBio and the North Shore Technology Council. Would you all please stand or wave so we can recognize you? I'd also like to give a shout out to Matt Cookson, the Executive Director of the Council, and to the all-volunteer Biotech MedTech Committee, and especially Committee Chair Cindy Condi. So, with a show of hands, how many of you have attended prior New Hampshire Tech Council events? Fair number, wow. And how many have attended Council Biotech MedTech events? Nice mix, good. So for those who are new to the council, we're a member-based organization with about 270 business and nonprofit members. We focus our efforts around 4 value pillars to support our membership, including advocacy at a state level, talent and workforce development, education and programming, and ecosystem engagement with our Tech Alliance partners. It's an exciting time for the Council and a great time to be involved. We recently announced an alliance with Alpha Loft to have a more focused approach to startups, launched a new members-only 401k plan, and are actively leading on increasing visibility for the biotech medtech sector, including tonight's event. The sector initiative was rejuvenated in January 2017 and is focused on advancing New Hampshire's leadership position, specifically in biotechnology, pharma, medical devices, and general health technology. The work the committee does is focused on providing high-value services and programs to support New Hampshire's ever-growing ecosystem of health-centric companies. Based on the response to our events in 2017, and certainly for tonight's sold-out event, this initiative is clearly gaining momentum. Among the companies in this space, there is a strong expressed desire to collaborate on common topics and unique challenges pertinent to the industry. These topics include emerging technologies and tools, workforce development, regulatory health policy, and business expansion. Our active and growing volunteer planning committee has 5 events planned for 2018, starting with tonight's New England regionally themed event, and 4 other industry events in May, July, September, and November. We will also have a presence at Bio International in Boston the week of June 4th. As you might gather, ARMI is a catalyst for bringing the broader industry together in support of an important national mission. It's on the radar screen of industry, academia, and government across the nation, and is providing a significant opportunity for New Hampshire to shine even brighter. Tonight we'll hear about the opportunities ARMI brings to New England, the nation, and to millions of individuals whose quality of life will be enhanced by access to organs that are not available in the current medical system. Gray Chinowith, Chief Membership Officer and Deputy Chief Operating Officer, Dr. Thomas Bolenbach, Chief Technology Officer, and of course Dean, as Acting Executive Director of ARMI, will give an update on this exciting and very significant initiative launched right here in the Manchester Mill Yard. After we hear from these 3 individuals, Cindy, our committee chair, will lead us in a Q&A session followed by an opportunity for more networking over food and drink. So before I turn this over to the ARMI team, I'd like to leave with a quote from Dean. So I'm going to channel my inner Dean Kamen. You'll just have to imagine the denim and the nicely well-pressed work shirt. Here's a quote. "How would the entire system of healthcare change and someone's personal health diagnosis change if we could print a new kidney or liver when you needed one? This will become a reality, and in the not-so-distant future, we will look back on our current medical system in disbelief at our limitations." So now I'm going to stop channeling my inner Dean because that's pretty intense, right? And I'd like to invite Gray on stage to kick things off from the ARMI side.
See if this works here. Well, that's always the way it should work, and then well, that's us. So this is where I'll kick it off. And so again, my name is Gray Chinowith, and I'm the Chief Membership Officer. And I'm really thrilled to be here with you guys tonight to talk a little bit more about how we're bringing a national community together around this very important mission. And I think it's very exciting for me to have joined this effort last year. I spent a long time working at a company called Dine just up the road that was very focused on trying to support the local ecosystem. And that's why it's just been such a thrill for me in this role to be part of another ecosystem that's really growing as we see the efforts of the New Hampshire High Technology Council to support the biotech ecosystem, and to see the companies that are coming to the fore, both in the regenerative medicine space, like the ones that are moving up, Advanced Solutions moving up from Tennessee, and all the other companies that are starting here in the state. So it's very exciting, and I think that goes to this quote by Aristotle, which is that the whole is greater than the sum of its parts. And that's really what we're trying to do here. we're trying to bring together an ecosystem, not just across the country, as you'll see in a moment of who's coming to the table, but across different sectors, across government, nonprofit, small companies, large companies, clinical institutions, really bringing together adjacent competencies that will really catalyze this industry. And I think, as you'll hear from Dean later, that's really why I think the DoD picked Dean as the founding person, the originator of this idea that we could bring together so many adjacent competencies. And I also think it's interesting because we're bringing all those people from around the country here to Manchester. I think the governor asked who had been in this room before, and I think the last time I was in this room talking to a group, we were in 2 feet of snow from the bomb cyclone, which was our very first event. We did get one snarky comment from someone who flew up from Florida that we should be holding the next event in January in Florida for BioFab USA, to which we replied, no thanks, we'll just hold one in June. So that's our next large event. But it really is this community and this ecosystem coming together. And I wanted to show this slide because I think the amazing work by Dean and Tom and the rest of the team in really putting forward our application. So I want to share the industry backing that we had to even apply to the government for the grant. And I think you can see names you've absolutely heard of, like GE and Boston Scientific, Lonza, Autodesk. But then there's lots of companies that you've never heard of before, like Epibone or Trailhead Biosystems or Advanced Solutions, who, if you haven't checked out their bioassembly bot, or their BAB as they call it, which they've located one here and they're going to be expanding their operation here in the mill yard this spring, you've got to come and check it out. It's amazing the type of technology that these companies are bringing together. And it's also amazing that they're starting to do it more and more here, whether they're starting here, coming to visit, or moving part of their operation here. So in addition to that amazing industry backing, we also have an incredible non-industry backing. Like I said, we've got amazing partners like UNH, who really has been a tremendous partner for us. If you haven't run into Mike DeSell and asked him what they're doing in a national context for workforce development as part of the ARMI project, you need to. It's amazing the type of work that they're doing, whether they're doing it here, they're collaborating and sponsoring things across the country, or they're doing unique events that really haven't been done before, like the BioAcademy program they're planning for later this spring. So beyond UNH, we obviously have people that are local, like Worcester Polytech, that's truly been a leader in this space. And then we've got people in Minnesota, and we've got people in Arizona. We've got people across the South, and we've got organizations beyond just academic institutions. We've got clinical institutions that are participating. And we have nonprofits that are participating that care about some of the cures that these therapies represent the opportunity for. So this amazing industry backing, this amazing non-industry backing brought us to the place in which we won this award. And what we've been doing since October of this year is really building out a national membership base. So all these people supported the application, but now, more than just a letter, now they're coming with money, relationships, investment in projects, and it's really amazing for me to see all these people across the country believing in what we're doing here in Manchester, believing in it so much that they're willing to come through a bomb cyclone and 2 feet of snow to come have that conversation. And I think it was really a testament at that talk. Dean challenged everyone to say, look to your left and look to your right. You probably haven't met that person before. And that's exactly what this organization is doing. We're bringing people together who haven't connected before, because what seems simple to the biologist seems complicated to the engineer, and what seems complicated to the engineer seems simple to the biologist. And by bringing those competencies together, we're really in a position to unleash some of this innovation and technology that really has been held up by the lack of collaboration in the field. So, as I said, we've got a national membership base that we're bringing together in furtherance of this cause. We've also got a national engagement strategy. So we're going across the country. I think we have more than 40 events this year. 2 core ones are going to be here in New Hampshire. We've got one scheduled in June, which is going to focus on technology and innovation. And we'll do another one in the fall that's focused on regulatory enhancements and standards and education workforce development. So we've got a fantastic agenda for here in New Hampshire, where we're bringing that entire national community together, but then we're also going out and we're evangelizing about the great opportunity that companies that are here are having from the ecosystem that's building, but also about promoting companies across the country. So the companies that are here, we're able to connect and discuss their competencies and capabilities in every single place that we're going to. And it's really been fascinating for us to talk at these events. In fact, next week, we're so popular, we have 2 events on the same day. Tom is speaking down at Worcester Polytech, and we'll have our regulatory, one of our regulatory leaders speaking out in Minnesota. So I think it's really a testament to the reach and the breadth of the interest in what we're doing here, and the excitement that people have when we do say, hey, let's bring this community together in Manchester, New Hampshire. So when I talk about exciting collaborators, I think these are a few, and this gives you a sense of how we carve up the industry a little bit. So we've got people like Cellink, who does 3D bioprinting and works in bioinks. They're going to be involved with UNH and the Bio Academy that's happening later this spring. We think about them as being involved in our raw materials, right? And that's going to certainly be a core component of enabling this industry, getting standard, scalable, dependable raw materials so that we can use those in the fabrication process. In addition to that, we've got Advanced Solutions, who, as I said, you can check out some of their technology right here down at the other end of the mill. And they're moving their team up here. We've actually had one of their team we're hosting them in our office downstairs until their space gets fitted up. But they've got an amazing work cell that has it's really a platform for biofabrication. And if you haven't seen it, it's a 6-axis robotic arm that you can load multiple different printer heads or tool sets onto to really move the situation forward. Instead of having another postdoc or running postdocs on 24-hour cycles, you can just run this machine and scale that manufacturing to clinical and beyond, which is what we're really trying to do to help the engineered tissues. Histogenics, just down in Waltham, another very exciting partner that we're thrilled to be collaborating with. It's amazing to think of, but they today are taking your cells, they're bringing them back to their lab, they're expanding them, they're creating your own cartilage, and they're shipping it back to people so they can put it into their knees. It's amazing to think about that it's happening, but it is, and they're right on the precipice of moving from that clinical stage to that commercial stage, which is why it's so exciting for us to be collaborating with them, because they're the perfect poster child of where we can really add value to them as they scale as a company. WPI, another great partner, as with DEKA, deep engineering experience, and really brings a lot of capabilities together, especially around sensing and imaging, which is really the next step in what we have to do. We find that the companies that are trying to develop these engineered tissues, they just don't have the tools to do it easily and scalably, and WPI is a great partner in bringing that together. They've done it in so many other industries, and we're excited that they're partnering with us on doing it here. And then the last one, in monitoring and measurement, companies like FluidScreen, just a very small startup, but has some amazing technology that we think will enable inline testing, and inline sterility testing, so that the product can really be developed with a quality by design approach, which allows you to understand whether or not, without destructive testing at the end, whether or not the tissue you're creating is really going to be useful. So I think these are some examples of the exciting collaborators that are coming together and coming together here in Manchester. And I think the take-home message is that the reason we have this much excitement is not just because we have an exciting goal, but because the organization is so focused on delivering a return on investment to the members that are coming to the table, whether they're industry or academic, large or small. We've designed this not only to leverage the $80 million that we have from the federal government, but to create that ecosystem and community that is really going to draw people together and really, as the governor said, plant that seed here in Manchester to be part of the larger, greater Boston ecosystem that is really a leader in the world in terms of life sciences. And the last point is just that we have really a growing ecosystem of partners. This is what we've done in the last 6 months, and we're so thrilled that we have had such energy and excitement. And I think to the governor's point, if we're able to add on top of that the catalyst of the federal money that we're able to invest, the industry backing that we have, the ecosystem of partners that are coming to the table, if we're able to add to that, just one more advantage of coming and being an early part of this ecosystem. It'll really be one more catalyst for growth that we see in the industry. So it's a very exciting time. It's a national network, and that national network, all of that interest, we are the access point for that here in Manchester. And I think you'll see we've already had companies that are moving here and opening up shop, and you'll only see more of that. And as that network builds, as we all know, network effect, it's really strong and powerful and will enable growth for all these companies and the industry as a whole. So it's a very exciting time for the organization. And I think, as I think Dean said, the room keeps on getting bigger, and we anticipate that to continue to be the case. So now that I've talked about the kind of the momentum and the coalition that's coming together to drive forward our mission, I'm going to hand it over to Tom, who's going to talk a little bit about what actually we're doing beyond just who's doing it. So thank you very much.
Thanks, Gray. So I have a couple of announcements. One is that the BAB robot that Gray described earlier is going to be demonstrated, I think, during the networking hour. But there should be another announcement at the end, but I just want to make sure everyone is aware of that. I also want to say that thanks to the governor's speech, I don't think I'll be going home tonight. I'm not going to tell you where I live, but I'll probably just stay in my office. And I don't want to say what state I live in, but Dean calls it Taxachusetts. And I was going to wait till my son is done high school, but I'll come up tonight. So I also want to level set everyone just by saying that what we're talking about here on the technical side is tissue engineering, and that is taking some sort of polymer scaffold or protein-based scaffold, combining it with human cells and incubating it in some manner that generates a bona fide human tissue, right? And so what I'm going to talk about is how we got here and why we're here. And I'll start by taking you back to 1999 and 2000. So the hype cycle for tissue engineering is at its peak. Investment in the industry is at an all-time high. And so that prompted Scientific American to publish an article promising that off-the-shelf human tissues and organs to treat congenital defects, disease, and trauma were just around the corner. And in 2000, Time magazine declared the #1 job of the new millennium, tissue engineer. And I'm sure that made my mother extremely proud. But by 2003, the wheels had come off and investment was dried up. And that's because two companies that were the darlings of tissue engineering, Organogenesis and Advanced Tissue Sciences, had filed Chapter 11 bankruptcy. And that's because what they figured out was that it wasn't very easy to scale. The tissues at the end were expensive, owing to high labor costs and frequent scrap rates because the tissues weren't made consistently. And that generating anything than a flat sheet or a tube was much more technically difficult than was originally anticipated. Then move to 2009, Organogenesis is out of bankruptcy protection and thriving, but they're really the only ones that are still around. And then let's go even further forward to 2012, 13, and 14, and the federal government has made a substantial investment into tissue engineering and regenerative medicine to the tune of around $3 billion. So the question is, where are all the tissues and organs we were promised back in 1999 and we're told were just around the corner, and why are they still just around the corner? And the problem is that the federal government had invested quite heavily in basic research and development to understand how to generate the tissues, but not in how to scale, make them consistent, and make them cheaper. And so that was recognized by a small interagency group in the federal government called MATES, and our Chief Regulatory Officer, Richard McFarland, is part of that working group. And they recognized the fact that there was a lack of understanding and investment into manufacturing engineered tissues that would really help us to deliver on that promise that was articulated by Scientific American back in 1999. And so they made a recommendation to the federal government, and Manufacturing USA to fund an institute that would focus on the scale and consistency of engineered tissues. And that's where the $80 million investment by the Department of Defense originated. So this is the challenge. We need a new future state for engineered tissue manufacturing. So on the left is a typical process, even done today. This is a technician making skin in a Class 100 clean room. And you scientists out there will recognize the common tools that we use as scientists to do what we do. That's pipettes, Petri dishes, etc. But the challenge here is that in order to scale that process, we need that technician replicated, so we just add labor, which makes the products more expensive. The technician is probably making decisions, making mistakes every once in a while, and that adds to the complexity of the manufacturing process. When what we really want is what's on the lower right, the future state in which we're using automation and retraining the technician to have other skills that are going to allow them to run many more lots of product using automation much more consistently. And so this is a table summarizing the where we are now and where we want to be. So currently, processes are labor intensive and require a clean room space to do unit operations. They're also conducted in ambient air in tissue culture hoods and so on. There's also dozens, and in the case of skin, thousands of manual unit operations involving those same pipettes and Petri dishes that I showed in the previous slide. Where we want to end up is with automated processes using automation, robotics, operations that are conducted in closed, non-classified spaces. So I always say I want to be able to generate a tissue manufacturing line in this room with this space and have it completely enclosed so that it can be done in a fully automated manner and won't get contaminated. Usually, these processes rely on a fixed process control strategy, and the fixed part is usually time. And what we really need is to understand and allow variability in our processes and use what's called quality by design principles, which really build the variability, the natural variability of a manufacturing process into the process and allow it to happen within bounds. And that's really important because the human cell is arguably the most variable raw material in any manufacturing process done today. So we need to understand that. The challenge, though, is that we don't understand the effect of individual unit operations on a human cell. We don't know what happens to the cell when it's centrifuged versus put through a pipe and concentrated. And that's a challenge. And then adding to that are highly variable and thousands of raw material components in the culture media that we need. There's also very little in-process data capture. Typically, these products are generated and then QC'd at the final step without any understanding of what may have contributed to the potential variability in the final product at the end. There's also a complex and tenuous supply chain, owing to the fact that some of the materials that we need to incorporate into the process are either exotic or not GMP qualified. And then the idea that we can take your tissue, your cells, and create a tissue out of it, individual to you, and then re-implant it is a daunting task because we can't mix the samples up. Mixing them up would cause a rejection event or worse. So how do we get to the future state? So we built over the course of several months last year a roadmap, which we've now completed. And that started with a manufacturing needs assessment where we asked the companies and suppliers to the companies that generate tissues today, which are mostly startups and small companies, what the challenges are to achieving consistent, scalable manufacturing process for quality-controlled engineered tissues. And so we've put together a roadmap, which we just completed in February, and that's being turned into project calls. And through those project calls, we solicit ideas on how to solve a particular manufacturing challenge for engineered tissues in various categories, which are articulated in the roadmap. And then fund projects using the $80 million investment in order to solve those problems. And these are just some examples. We have a project with, between Trailhead Biosystems, a company in Ohio, Biogen, and we have someone from Biogen here tonight, and Arizona State University, to understand the variability in cell manufacturing on its own. We have real-time and label-free sensors for viability of tissues, for the sterility of tissues. Several projects on fully automated and non-invasive monitoring for the validation of biofabricated tissues. So understanding what those markers are that tell us that the final product is of sufficient quality and being able to measure those, which hasn't been done before. Centralized fluid management. So if we have 50 trays of skin, like we saw in one of the previous slides, we don't want the technician to be feeding those individually because there could be errors made, et cetera. We want a centralized fluid handling system that's just going to feed all of them when the tissue demands that it needs to be fed. And then a few projects, one of which is one that's being led by Advanced Solutions Life Sciences, using the BAB robot that we have here, on generating dynamic vascularized tissues. And this really speaks to the ability to generate a tissue that's thicker than just a sheet of skin or a tube like an esophagus or a trachea, and really get to the point where we can manufacture solid organs. And that's going to be very key for the future. And then two different projects that really speak to developing micro tissues in petri dishes that we can use to better screen drugs and biopharmaceuticals. We also like to think of this as not a collection of project calls and projects that's being done, but we really take a systems engineering approach in the spirit of DEKA and bring all of these projects together so that at the end of the day we have a comprehensive fabrication system that'll be able to take a sample, a blood sample or a sample of skin, generate the necessary cell types that we need to generate a tissue or organ and fabricate them automatically. And so really what this is doing is taking the various projects on cell phenotype and function control using precisely engineered culture media, durable pumping and valving. Some of these processes are going to take 10 weeks or 12 weeks to complete, and we need something other than a peristaltic pump that may break down and leave fragments in the culture media. We need data capture and storage, which is a much bigger problem than it seems initially. Taking data from various sensors that are sampling at different frequencies and rates and coalescing that data in order to control the process. Non-invasive culturing, non-invasive monitoring of critical process parameters. And then coming at this from a perspective that FDA is going to favor much more than what's currently done, and that is to collect as much data as possible at the very beginning of process development activities. And so, in summary, a systems engineering approach to generate that fab line that we can set up in a room like this and have a highly skilled technician who's trained on the automation run on their own. And I think with that, I would like to turn it over to Dean for the third talk. Thanks.
So now you've heard from the governor. You've heard from some specifically competent people to tell you where we've been and I hope where we're going. I'm not going to add much to that. I may add nothing to that. You need audio as well there, right, boss?
Yep, audio's coming through.
So the deal I made when Gray and Tom said I should speak was they have to do all the heavy lifting and give you an update. What I told them I would try to do is remind everybody why we're here at a high level. And I will apologize to all of you that have maybe been at the opening that we did about a year ago. because I'm using some of the same slides. I also put together, or they put together for me, basically 3 pieces. One is a set of slides which, based on the time, I'm just going to run through them to give you maybe some of a history that I hope shows that we have some credibility to do things that, at least when we started them, most people thought were nuts or too risky. Almost every technology I can think of went from indefensible to indispensable because some small group of people said, yeah, we can do that. So I'm going to give you a quick history, not to be bragging about it, but to show you the context and what I and my little company next door, DEKA, which now has 3 buildings full of engineers over there and most of this building, what we've been doing for the last 20 or 30 years up here after doing it for 10 years down in New York. And a lot of the technologies you'll see either demonstrate stuff that we want to bring to the new problem of bringing these engineering capabilities and disciplines to regenerative medicine, and in some ways to show that it really does matter that you take people outside their comfort zone, outside the normal field that's been playing with a problem, bring new people to an old problem, bring them from a different field, and you sometimes get a really transformational solution as opposed to an incremental improvement. That's the first third. Then I am going to show you some of the slides, maybe the context for them that both the governor pointed out. We did win for New Hampshire the opportunity to build this place here, and we certainly didn't do it because we put more money on the table than California, Texas, New York. The governor was being accurate, and almost, it's funny, these other states started offering more and more money when it looked like they weren't going to win it. They went from 200 to 500 million. They want this place. After spending a lot of time with our government in this little state that doesn't spend a lot of money, they don't have a lot of money, remember? No income tax, no sales tax. They believe government should stay out of that. After many, many meetings and that final presentation, when I was telling them these other states, one of them was up to nearly $1 billion, I got a note that the state would be able to commit 425, I said, 425 million, 425,000, but only over 3 years, and they couldn't assure me that they could deliver it. $425,000. So I ran up there and begged them not to send the letter. I begged them. The humiliation, it would be too much. So we sent in our proposal without even mentioning what the state was willing to come up with as a direct financial support. We still won. That says a lot, I think, about the ideas that we'll show you and why we think we can bring a unique perspective to turning all these science fair projects that are happening in all these medical schools into a system that can really change healthcare and build an industry and build the environment locally. So that's my little company. This is the kind of thing I was building in my parents' basement back in New York when I started building ones. A little bigger than this for my brother, who was in med school and later a professor at Yale Medical School. But the point was, I was just taking engineering at the cutting edge of low power electronics that could build counters and timers and little displays back then and apply it to a need. I didn't make the first insulin pump. I made it for delivering chemo to babies because my brother's a pediatric oncologist. But he would be proud of what his little brother delivered to him, and he would show it to his professors, including people in diabetes care. So it went from a sort of a gift I made for my brother to help him do his pediatric research on a very rare disease for which there's no market, besides brothers don't pay you anything, to the opportunity to create a product that later became the insulin pump. We sold that business a number of years later. MiniMed got sold a few more years after that to Medtronic for $4 billion. They make one product that looks remarkably like this. We started making things like home dialysis. Again, we were told it's unlikely people are ever going to deliver essentially life support to themselves, end-stage renal failure patients, at home every night in their bedroom with a device at their bedside with a little window on it that they could load cassettes into. I mean, we were literally told we were nuts, which is always a good way to start a project. Because if you're wrong, well, you couldn't do it either. And if you're right, it's transformative. It worked. This is the standard of care for peritoneal patients around the world now. We've shipped something in the order of 600 million cassettes for this thing. I show this as a stent. We didn't invent the stent, but we worked in our little company to make a major practical improvement in stents for, at the time, the largest medical products company in the world, J&J. But I had been working on other projects with them, and they asked us to help do this. I'm flying back from their headquarters in New Jersey thinking, it's metallurgy. It's a piece of 316 stainless steel. It's got to be able to go past elastic deformation. It's got to be able to be expanded to within 5% of fracture, yield, destruction. You know, that's not a skill set most of my engineers have up here. And it occurred to me, the aerospace industry deals with structural issues, fatigue life issues of exotic metals. They've been doing that for 40 years. They want to make everything in an aircraft as light as it can possibly be, but not lighter than that. And it occurred to me, I happen to have a little aerospace company. That's me flying that thing. I built helicopters at the time. I built about 1,000 of these things, and I have some very good aerospace engineers out there, and you know, they make all these parts very light. They got to go through a few 100 million cycles, and you never want that little nut on top of that thing to go bad. It'd ruin your whole day. So I brought some of them in to work with some of the engineers I already have here and said, you must have better analytic tools, computer modeling tools that we can use to do this job. And in a very short time, it was weeks, they came up with a much better design for that stent because they brought a different perspective. They're not interventional cardiologists like the guys that conceived of the idea of a stent. They just were able to bring from another industry some pretty standard solutions to make quantum leaps in the performance of that product. We made an iBot, the thing that the then President of the United States in part gave us the National Medal of Technology for. One could argue it was way ahead of its time. It had solid-state gyros that at the time cost thousands of dollars. It had 60 pounds of batteries that were nickel cadmium. But what it could offer to somebody that can't stand up, that can't walk, that can't climb a curb or stairs was remarkable. And again, it had a lot of technology that's similar stuff that you have in autopilots in helicopters and airplanes, stabilized system. Turns out they were very, very expensive to make. We put about 500 of them in the field, and I don't think the regulatory or the reimbursement system of the country ever properly adjusted to the impact of what this could do for people. This is not a wheelchair. I'm happy to say that we never give up, and after manufacturing was discontinued because I think the technology was ahead of public policy, we started again recently, and this thing sitting next to it, we just, in the last couple of weeks, got the FDA approval on. We got the FDA approval on it in Class 2 as opposed to Class 3. In Class 3, you can't change anything, like a pacemaker. But we demonstrated that we had 10 million hours of operation on this balancing thing, and not a single one ever went down because of a system failure, because we had so much redundancy. And we went back to the FDA 15 years later and said, come on, now it's time to make this more available. And in that new one, we've got all the electronics on one little board, solid-state gyros and accelerometers that fit on a postage stamp, lithium batteries that weigh a quarter of what the original ones weighed and have twice the energy to go all day. The machine weighs 100 pounds less than the first one. And we're about to relaunch a whole company to make them available, and that company's probably going to be in this building or the building next door. From that, idea 15 years ago or more, how do we get rid of that? From this idea of a balancing device which is yet another medical device. I've spent my whole life on medical devices. We realized it was one of those rare medical devices that we had learned how to do something that might be useful in another field. You know, nobody ever said, boy, that dialysis machine looks like so much fun. I can't wait till I have end-stage renal failure and I can try it out. I mean, nobody ever wants to use the products we make. They're just happy that they're there when they need them. But you could take the seat off this thing. You could use all that balancing. You could all those servo motors, all those accelerometers, all those gyroscopes, and you could make this thing, which we did, and their factories down the road. But the funny thing is, it's the one sort of non-medical thing we ever made, and even it came from one of our medical things, but forever, I'm the Segway guy. So we also have been making prototypes of ways to make electricity with a Stirling cycle generator, make clean water with a vapor compression distiller, and we decided that we could get those out around the world if we had a partner that knows how to do that. It turns out the big medical companies of the world, as big as they are, do business in 50, 60, 70, 80, 100 countries. There are 200 countries on the planet, and about 100 of them are so poor, they don't buy medical equipment. They don't have medical systems. But there's one company that can get products anywhere. They've been making, manufacturing, bottling their product for 125 years. And we said, help us put our little boxes. That little black box that makes water, let's get it into every village, clinic, school in the world. So we went to these guys, Coca-Cola. They said, well, actually, we got a problem of our own. We'd like a machine that in real time can manufacture any one of our beverages. You're a medical company that mixes and measures and controls fluid with great precision, dialysis, drug delivery. We made an agreement with them. We'll build you a machine that will do that for you. If we exceed your expectations, we'll ask you to help us, see if we can do a trial to bring clean water to the world with another one of those Dean's crazy ideas. Let's build a miniature distiller and make anything from toxic waste in a latrine or a cesspool or a salty ocean into water for people. We exceeded their expectation. We built, I don't know, there's more than 40,000 of these things out there now. The chairman of that company said, a deal's a deal. We'll help you do a trial with your water machine. Now, they're not a very high-tech company, but their chairman did say, Dean, could you make one change to that black box you showed us? Can you make it red? So we did. That's the chairman of the Coca-Cola company at the last Olympics, not Korea, London, with Will.i.am and some other people. The point is, as I keep saying, exciting things happen when you go outside your comfort zone, not just of technology, but of who you need for partners. Coca-Cola has the largest, most effective global distribution network the world's ever seen. Why not use them to help deliver things like water and healthcare? So we did that trial, but we need to get that water machine to scale. We need another application for the water machine that the rich world would need it for, in the same way that iBots needed the volume of Segways. And it turns out our peritoneal dialysis machine is really good for the people that are amenable to peritoneal dialysis. But there are many patients, end-stage renal failure patients, that need the old-fashioned hemodialysis. Your blood gets taken out of your body, it runs through an artificial kidney and gets put back into your body, but the outside of that dialyzer, that artificial kidney, is being flushed with 50 or 60 gallons of pure medical-grade water every day. So you need to go to one of these dialysis clinics every other day to be dialyzed. And we said, no, we can make medical-grade water in somebody's house with our miniature vapor compression distiller. We'll put that red box into something a little smaller, and we'll put a hemodialysis machine on top of it, and we'll get to scale with this water production technology for the medical application like an iBot, and justify the large scale by putting it out for a few billion people that need clean water. I'm happy to tell you we have now finished the design and are preparing for our second set of clinical trials on a home hemodialysis machine. This machine is sitting on top of that water machine, which can work in somebody's home. And if it gets through the FDA, if it becomes a reality, it could be a huge impact on healthcare and the cost of healthcare in this country. I show this because it's in part, I think, why the Department of Defense ended up giving us the opportunity to build ARMI here, even though, as I said, I can assure you, we weren't the ones that came to them with the most history or the most matching resources. But more than 10 years ago, they asked me to help build the next generation of prosthetic limb for some of these returning young soldiers we have that typically, due to an IED, were injured to the extent they lost an arm or two. And we, in fact, made one. We did some trials with it. There it is. That's literally next door. This is one of our old home videos of a guy that's missing both of his arms. He's punching one of our controls engineers. The guy standing behind him is an engineer who also happens to be a Harvard-trained surgeon. They now showed a little fine motor control, but again, this is probably the one video from this whole project that I show over and over and over again. It's a very early one, but this guy, Chuck, in a second is going to pick up a spoon, start eating cereal with milk and cereal, holding the spoon level with a prosthetic hand. There he goes, and at the wrist and the elbow and the shoulder, and he eats it without even dropping any milk, which I can't do. And his wife is standing behind me crying and saying, Dean, he hasn't fed himself in 19 years, so either we keep that arm or you keep Chuck. So now he picks up the grape, which is what the military asked me for. I want him to have fine motor control, and he does. Well, that was the Model T. And a couple of years ago, after, I won't say fighting with them, after having energized discussions with the Food and Drug Administration, we were able to take that Model T and turn it into this. And we have now put a bunch of them on people that certainly deserve them, people that have literally given their arms for this country. A few weeks ago, here at the local VA, in front of our senator, by the way, we took for the first time ever a guy that was missing one of his arms, that had been wearing one for a couple of months, and it was so impactful on him. He went back to them and petitioned to get a second one. He's bilateral. And we ended up putting a second arm on this guy, and after a little bit of practice, he walked out in front of his docs, the VA, and our senator, and he opened both his arms and said, I'm ambidextrous now, which was truly astounding to us. There's not a very big market for these things. We didn't do it for that. In fact, we offered to give the technology to any of the big companies that make prosthetic devices. Nobody would do it. The technology was so far beyond the stuff they make, and the quantity they would make is so small they didn't want to deal with it. So we sucked it up and said, we'll start a company right here again, next building, and we'll just start building the arms here for that small group of people that need them. I think our commitment to these projects convinced the Department of Defense that we mean what we say what we mean, and when they ask us to do something, we deliver. It's with those projects as a backdrop that we ended up, I'll say, bidding on the opportunity to do what the Department of Defense asked us to do, which was not basic research. They didn't want to do research on arms. They want to put this stuff on people that need it. So that brings us to ARMI. A little over a year ago, we got that award, and in January of last year, we started feverishly trying to build the partnerships to make this real. This is the mission statement that we put in our proposal. The whole point of it was it's engineering based. For decades now, the National Institutes of Health, the National Science Foundation, medical schools, research labs have poured money, wisely by the way, into understanding genomics and proteomics and cell biology. I mean, all the incredible stuff that they've accomplished. And they're damn good at it. And all over the country already, for years, they've demonstrated that they understand some things about how to create living tissue, how to do cell expand. I mean, the science they have. And the analogy we kept giving to the DOD as to why we were going after this was, you know, Grandma knows how to make chicken soup. And she makes better and better chicken soup. Now that she's a grandma, she's making it for a lifetime. And everybody wants to go and get Grandma's chicken soup. But if you ask Grandma, how does she make it? Well, first of all, it's a secret. But it's a pinch of this and a dash of that. And there it is. It's Grandma's magic chicken soup, just like these docks that have these roller bottles and Petri dishes with this magic in it. It'll win this guy the Nobel Prize. It'll win that guy tenure. It'll win this guy the cover of Nature magazine. But we said, you know what? Grandma, no matter how many people want more soup, if so many people want more soup, the way she would scale up is she'd hire another grandma from next door. They'd put 2 people in the kitchen. Grandma's not going to show up one day, even after she has a perfect recipe for chicken soup. She's not going to suddenly have all the skill sets to do canning. Grandma will never become Campbell's. And if she tried to do all of that, the government would appropriately say, Grandma, how do we know the second can is just like the first or the millionth can? How do we know it's safe and reliable? I mean, verification, validation, process control, FDA approval. That's not what happens in these research labs. So we went in our proposal and we started showing them data that looks like this. People fund all that basic research, that first big lump to the tune of billions of dollars. And once everybody knows it's going to work, there's no shortage of investors. And big pharma, you know, whether it's Roche, Pfizer, or the big companies that make the hardware, the Medtronics or Jane, there's no shortage there. But when you take something as complex, as difficult, as risky as let's go figure out how to manufacture entire human organs, the time frame is too long for the venture capitalists, the risk is, it wasn't happening. We said we are going to focus on one and only one problem. We're not going to do basic research. We're going to find all the people that have these miracles in their roller bottles and Petri dishes. We're going to partner up with them, and whether it's Grandma's chicken soup or somebody else's magic, we're just going to figure out how to deliver to them the capability of Campbell's. We're going to figure out how to take this stuff out of the laboratory and turn it into high quality, high volume, FDA approved, finished organs or tissues or pieces of tissues that people need. Why? They wanted to know, could we do it in New Hampshire? You have to remember, there's a lot of skepticism in Washington. Well, we pointed out that from the 1840s to the 1870s, this is actually a picture of a giant picture that was delivered to us by the Manchester Historic Society. There's a giant 12-foot of these in the lobby next door. But this is, in 1876, they did this map. And at that time, the Amoskeag Mill Yard was the largest single operating industrial complex in the United States. It produced 600 miles of meter-wide fabric per day. Well, if you had a 10-hour day, I realized they were longer back then. That says you're producing fabric in a 10-hour at a rate of 60 miles per hour of fabric. Now, it took 22,000 knitting machines and looms, but it was astounding. But they were able to do it, and they did it here. We said we can do it again. This building right here, if you look out that window, these little windows, that's the building right behind us. This picture was taken at an unhappy day when the big strike went on that pretty much closed these mills and they never reopened. We moved up here. By the way, I didn't call this the Millennial Marvel. This is Politico did that conveniently at a time when we're trying to convince them that New Hampshire is the place to start a new Millennial Marvel. But the article basically says this city is the right place to have this resurgence. This is a picture I took from my helicopter coming in to land at this helipad, which is directly out that window, about 50 feet. If you don't fall, you'll end up on the helipad. I moved up here in '82, as the governor said, because I liked your license plates. Over the years, we started putting more and more stuff in here. We put FIRST across the street. It's now a 150,000-foot building full of FIRST with a couple of hundred full-time people running it. We got Autodesk up here. We've got Texas Instruments up here. The first company that we're actually working with that's producing products based on regenerative medicine, United Therapeutics. Now we have the entire University of New Hampshire in what used to be called the Pandora Building. This is where we're going to build ARMS, which is right next door, and probably iBots. And the building we're in, ARMI. This mill yard is beautiful, it's historic, it's timeless. It's right at the center of what I think is the population base to make ARMI really work. If you drew an X from Dartmouth and their med center and their engineering school down to the southeast from where they are to Harvard and MIT and BU and Tufts, and then you went to the northeast and you went to University of New Hampshire at Durham and you drew another line to make an X down to University of Lowell, UMass Med School, WPI, that all share a little campus. If you drew that X, the cross point of that X is this mill yard. This is the perfect place to do this. You don't need a long growing season for this new industry. You don't need massive amounts of energy like for the automotive industry. This is a clean, high-tech industry. It's got to start somewhere, but it's so complex that just like the semiconductor industry that needs a whole infrastructure of people that can design chips, write hardware, software, systems, make wafers, the whole infrastructure to build human tissue is going to be remarkably sophisticated, and it's going to need lots and lots of tools invented to make it all work. It's going to need a lot of changes in the way regulatory processes are evaluated. We brought in, and I'm sorry he's not going to speak tonight, a senior guy with 17 years of seniority at the Food and Drug Administration, an MD, PhD, who is the policy guy at CBER, the guy that does this work for the FDA. After he saw our proposal and saw what we said we were going to do, he resigned from his senior position at the FDA, packed up his mini, moved up here, lives across in one of the lofts right here, and he's really our first most senior guy. He's now brought a few others from the FDA. We can tweak them a little more, but we just as soon have more expertise on developing these processes up here than anywhere in the world, because that'll help all of our constituents. I'm going to show you a little first for two reasons. One is, anybody that knows me knows, I am unwilling to go anywhere unless I get to pitch first. But really, I'm going to end with this, and it's only literally 3 slides. I'm going to end with it for another reason. I figure after I tell people we can create from whole cloth a whole new industry for this country, regenerative medicine, and it should be here, some people tend to be skeptical. So for maybe a way to let you give up some of your skepticism, I stood around about 25 years ago in the building next door and said, we should build a coalition of industry, of universities, of government that can help change the culture of this country, because right now kids all over this country spend all their time really aspiring to be really good at the only 2 things we celebrate in our culture: sports and entertainment. Hollywood, the NBA, the NFL. What do you expect from these kids? In a free culture, you get what you celebrate. So I said, we know it works. Let's make a sport, and let's make it entertaining. But instead of developing the skill of bounce, 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 throw, which is a really valuable skill for 5 people on every NBA team, and a pretty marginal skill for the other 400 million people, let's develop the skill of analytic thinking, inventing, solving problems, engineering. And then all these kids can participate in our sport at first, but it'll be the only sport where every kid on every team can turn pro. We started with 22 or 23 teams competing with a little kit 26 years ago. The second year, By the way, the entire world was in a high school gym in Manchester, New Hampshire for that first year, even though it took teams from 26 different states to come here and participate. I gave one kit to Boeing in Seattle and one to Texas Central, all these teams that you see. Well, it turns out we kept doubling and doubling and doubling. And now, this year, FIRST had 61,000 schools. It has 200 universities that this year gave us $75 million in scholarships that we'll be handing out at the championship in Houston, Texas, in the Astrodome in about 3 weeks. We have 3,500 corporate sponsors. The reason that I want to show you first, you'll see, didn't I see a lot of those names on those other slides that you just saw? Yes. Smart leadership in a big company that gets it, the same people that they better get involved in FIRST 25 years ago if they want a workforce of the future, if they care about their community, their country, the world. I figured after developing the credibility with most of these big guys, every Fortune 500 tech giant is a supporter of FIRST, I could call on these guys and tell them, thanks for helping FIRST. We'll return the favor. We'll help you become part of creating a whole new industry. And if you want to look at the overlap between the 3,500 corporate sponsors FIRST has and the 82 partners that ARMI has, we were told by the Department of Defense they were going to give us $80 million to anybody that won the contract. But we'd have to match it at least dollar for dollar. And as you know, the state, over 3 years, would give us $425,000. Which would be a good start. But I started making phone calls, and I'm a little late at this, and I don't normally raise money this way. Well, we didn't raise $80 million of matching funds. By the time we sent in our final proposal, we had $214.5 million of matching funds, which brought our total to nearly $300 million. And I think it's in part because some of these big organizations and some of these universities said, yeah, if you give people the right task and the right vision, and you never give up, they'll help you. These are the universities. This is last year's slide. It's not 50 now, it's 75 million. And most of you would like to have companies with growth like this, but this is the number of teams we had. And again, this is last year's slide. It's now 61,000. This is my last slide, but I do have a 1 minute and 59 second, I had to keep it under 2 minutes, video to show you. People that know FIRST know I used to show year after year the voice of God, Morgan Freeman, who used to come to our championships and he would explain to the world what FIRST is. And it would be a great narration. And he would show the kids at all the different levels, doing all the things. But as I started making FIRST bigger and going more global, I realized if you just keep telling people you have a robotics program, it's too easy for people don't like to change. And these moms are intimidated by tech, and these dads, and this company says we're not. And if you tell people you got to get involved in robots, you're going to give advantage to the advantaged. If you tell people join ARMI, well, it didn't exist before, why do I need? To get people to change, it's not telling them what to do. They have to understand why they're doing it, what the upside is. So I went to a friend I have in New York who produces powerful shows, major, he's a very famous producer. And I said, you'd think it was hard to give me the what FIRST is videos when I gave you the voice of God. I now need why FIRST is. It's never been about the robots. John, it's just never been about the robots. It's about self-respect. It's about giving kids the right role model. It's about showing them they can communicate, they can cooperate, they can coordinate, they can solve problems, they can build themselves a way to get out of poverty, they can create whole. It's never been about the robots. The robots, John, are just, no pun intended, a vehicle to get to kids, to have them. Anyway, after about, 2 hours, he puts down his pen, he's pretty disgusted, and he says, Dean, you want in 2 minutes me to give you a video that explains why FIRST is why. That's a big idea. That is harder than what. You're right. He said, but also in my notes, the only thing you've said over and over and over and over again is, it's not about the robots. But Dean, I go to your events all the time. He's in New York. He goes to the New York Regional. I'm heading down to the New York Regional tomorrow. It's one of the 160 cities holding regionals throughout March. He says, Dean, I go to all your first events. You keep saying it's not about the robots? I go to the events. It's all about robots. John, you know what I mean. I'm thinking he's going to tell me I can't give you a why you need first for this world, why every kid needs it, why the world needs it. So I throw in, I'm going to get you, the voice of God again, figuring that's my ace. He loves working with Morgan. And he says, Dean, to do what you want now, I don't need Morgan Freeman. I need a 7-year-old girl. So he made the video. I started sending it around the world. And for our World Championship of First, which we're going to have in August, we have more than 160 countries sending a team of kids. And all these kids from all these countries and all these languages are communicating, cooperating, and solving problems together. So this is why there's a first. We need audio.
This isn't a robot.
Can you hear it?
It very well may have hydraulic arms, a drivetrain, and a circuit board, but this isn't a robot. This is a lesson in humility, hard work,
Stay calm. No pressure. Try this.
Said you had a copy on this computer, right? It's out of juice.
You got a computer there? Somebody? You have it on there?
60 seconds. Yeah, I just ran out of juice.
Then let's plug it in. We were so close. We were really close. Oh, there it is.
This isn't a robot. It very well may.
It's worth seeing it twice.
This isn't a robot. It very well may have hydraulic arms, a drivetrain, and a circuit board, but this isn't a robot. This is a lesson in humility, hard work, and collaboration. This is a CrossFit workout for the muscle upstairs. This is an apple for the next generation of Newtons. It's a lot of things. But this isn't a robot. This is a roadmap that leads straight to engineering. This is a rock to shatter 1,000 glass ceilings. A rope to pull a generation up and out of poverty. A sledgehammer to break down cultural barriers. And a universal language spoken in every nation on earth. And because of that, this is a compass that can help point the way to peace. But please, don't think this is just a robot. This is Glastonbury for technology. This is mission control for the next moonshot. This is the Rosetta Stone to help translate the future. This is the sport that will help us win tomorrow. This is the software to program ourselves to cure cancer, build a clean engine, or step foot on Mars. But this isn't a robot. It's a machine to build the people who will change the world.
So I show you that, and you could say, what has that got to do with ARMI? Over 25 years, if you look at the growth of FIRST, which, by the way, is still now has its world headquarters in New Hampshire, with 200 jobs across the street, with 140,000 volunteers supporting it around the world. But it's a tiny, tiny little thing. It's a not-for-profit organization. What's going to happen if, over the next 5 or 10 or 15 years, we take a same kind of focus on a vision and a task to take on the problem of creating human organs to solve the needs of people that are going to die or be miserable without what we can offer? What if we have the same kind of focus and tenacity to build in this community an industry like ARMI in the same way we now have the world headquarters of an organization that's going to create the first global network of kids that know how to stop generation after generation of self-inflicted wounds of their parents, that are learning how to communicate and cooperate. What if little New Hampshire, because we're small, because we can quickly react, because we can all pull this thing in the same direction, because we have maybe a governor and senators and people that'll say, yeah, this is a little crazy. Most states would take years to figure out. We're going to jump on this. We'll seize this opportunity. Yeah, we're small, but when you're small, you make use of what? Small things are more agile. I wouldn't put an elephant against an ant. Here we are. I'm begging everybody in this state to figure out how collectively the medical community, the engineering community, the manufacturing community, the education community, workforce development here with if we can plant the seeds and make this the place that the best of young people that want to get into this new field want to come, it's a self-fulfilling prophecy. If we can get this to be the place that big pharma says, I need to know what's going on, I need a seat at the table up there. That's why we have 82 members. We have 26 medical institutions. We've got to create quickly such a powerful story up here that this is where the world will come for the solutions to these desperately needed problems. And by the way, if you want to know the scale, everybody's saying today 18% of the GDP of the United States is healthcare. It's going to be double that over the next decade, whether you like it or not. It will be double that. And you're either going to be on this bus or under it. So we should seize this opportunity. I don't know what each one of you do, but there's no one company, there's no one school that can do it. There's bigger organizations out there that are trying. We need to collectively do this, and we need to do it quickly. And that's what I'm hoping everybody here wants to do. So that's all I got to say.
Wow. Thank you, Dean, Tom, and Gray. I'm going to ask you guys to come on up because we're going to do a Q&A. I know that we're running a little bit behind schedule, and I really appreciate and thank you all for your patience. We will have a reception shortly after the Q&A, but I did want to give the audience the opportunity to ask questions about ARMI, BioFab USA. We talked a lot about, what Dean's role is and the group's role in trying to connect the dots and bring people together. Seems like an easy thing, but it's a challenging thing. If it was easy, everybody would be doing it. We would already have these solutions in place. This is one of the reasons why we brought this group together, because If you don't know much about what's going on, you want to get more involved, there's probably opportunities, I would say there's most certainly opportunities to collaborate and get on this bus. So with that, we have a microphone? Okay, so does anybody have any questions? Okay, so is that over here?
The bunch over there.
All right.
First of all, delightful. Thank you very much, Dean. My main question is, do we have a curriculum or identified a tentative curriculum for students to go through in the right direction here, so as the facilities here build up, we can deliver that workforce?
Thank you, thank you, thank you, thank you. I did not plant that question, but I love that question. The answer is no, we don't have a curriculum. We're developing probably no less than 5 curricula. We need to get kids early enough into this that they aspire to do it, so that by the time they're even getting through K through 12, they have the interest, the passion, and the background. Then the community colleges need to create the workforce that's going to start working in the factories. That everybody thinks it's that guy with the mask and the 3 PhDs and the postdoc. Yeah, they can make one of these things every 3 years to get a... We have 400,000 people now sitting, waiting for an organ to be donated, like a liver or a kidney. 25% of them die every year waiting. We need massive capability to manufacture all this stuff, and people are going to do that. Yes, we're going to help with robots and all sorts of other things, but people have to design and build and run those things too. So we need curricula for the people that'll man this new industry that will replace the textiles that were here. Then we need the curriculum for the engineering schools and the med schools that will take people across the barriers that have left engineering and medicine apart, which is why this thing hasn't moved quickly enough. And the whole premise of ARMI is to put them together. But now we need one more new curriculum. At our last meeting here, it turned out we were talking to the head of USIS, the biggest and only medical school run by the United States military, the Department of Defense. And we're talking to them saying, you know, let's say we can manufacture organs. Here they are, it's in a bag. What are you going to do now? The surgeons, the medical community, the entire support structure. It's not like you hit a double click on Amazon. And how are you going to integrate into medical care the ability to deliver, physically deliver these things and then implant them? They're different than an organ that you got from a donor or a cadaver. They're different in every way. They should be designed and built preemptively. You know somebody's going to soon need that liver or that kidney. Get some of their cells out of them. Talk to the guy that knows magic goo, who says, Dean, I'll just turn them into iPSCs, induced pluripotent stem cells. Then I'll go put them back in the scaffold and I'll build a new kidney, but I'll build it out of your cells. So when we put it back into you, you won't spend the rest of your life either rejecting it and needing another one because it was foreign, or taking massive doses of immunosuppressives so that you don't reject the organ, but now your immune system's suppressed, so you're going to die of a cold. So we need a whole curriculum to create a whole new class of professional people at the border between surgeons and people that do advanced engineering. The University of New Hampshire is a major partner, and a major piece of the $80 million we got from the feds is for what they call workforce development. We've got to build all of that. And once again, if we can be on the leading edge of building all of those things, building that curriculum, for instance, that's not really a medical school curriculum for these surgeons, it's a postdoc or a fellowship. Why don't we do that right here? Then the best surgeons from around the world, the best transplant surgeons all over the country are going to have to come here and learn how to do it. They'll probably stay here. You know, it's nice that the Mayo Clinic's out there. It's nice that the Cleveland Clinic's down there. But wouldn't it be nice if this became the center of the world for these advanced delivery systems, and we train all the physicians in the world to use the magic that's being manufactured right here? So yes, we need curriculum. We're working on it. I don't know what your background is, but if you're a professor, if you're a teacher, whatever it takes, we need to develop all that, and we're planning to do it.
So it's never too early to be thinking about FDA approval. Are you already targeting the patient advocacy groups to drive the demand for clinical trials and approval?
Is there a doctor in the house? He's not here. So as I said to you, we put our proposal in, and I almost kiddingly, I was invited to a press conference at the White House where they were announcing the award of this program. I'm standing at a microphone, and as you can all tell, I am genetically incapable of not being sarcastic. So after I was thanking everybody for trusting us to do this and giving this contract to New Hampshire, I said, and I know that the Department of Defense is very eager to get these things out quickly, and we've committed to get at least something out there literally on people within 5 years, which might seem aggressive if you're making the next software app or Angry Birds. But I said, and I was being somewhat sarcastic, I said, that's a very aggressive thing to do because just FDA approval alone on incrementally improved products these days can take 3, 4, 5 years. This is not an incremental change. And I don't know how long it's going to take the FDA. They don't even have the tool sets to figure out how to make this work. And I wasn't being critical. Well, I finish, I come off the stage, a guy hands me a card. I can see in the corner of the card that at least my core business is medical stuff. So in the corner of the card, I see that very specific little logo, FDA. Now, he's government, they're here to help. And the guy gives me the card, and I figured, here it comes. You guys are always blaming us for everything. You're trying to... The guy hands me his card, and he says, Dean, your vision for doing this is the only one I've seen that might actually be able to get through the FDA, bringing discipline, verification, validation, process control. We know you guys do that. Most of the people that come to us with these petri dishes full of stuff, they don't even understand the process. They can't even make a second one because the grad student left. He looks at me and he says, you need the FDA. In my comment, I said something like, if we're going to do this, it's so radically different. Instead of having companies throw this stuff over the fence to the FDA and get it, they need to be on our side of the table to help us develop this. He said, I agree with your comments. You do need the FDA on your side. He says, by the way, my name is Richard McFarland. I'm an MD, PhD, who left research, and I've been at the Food and Drug Administration. I'm now the senior policy guy on biologics, 17 years of seniority. He then says, by the way, if you were really serious about doing this, I'll resign from the FDA, and I never thought I'd say that to anybody. I'll pack up my office, I'll move up to New Hampshire, and I'll start right now helping you build the curriculum you need and build the processes you need to let all these different players build stuff that will actually get through the FDA. Within a few months, he resigned. He's, as I said, living across the street. His office is downstairs, and the only reason he's not in this room right now is he's probably out representing ARMI at some event either in Washington or San Francisco or somewhere. The answer to your question is the FDA is going to be critical to this process. We understand that. We're working with them, and we think they will be on our side of the table.
Other questions? Okay, we have one more over here, and we'll probably break it at that point.
Great presentation. So what would you like to see from the local engineering community? Do you have a list of skill sets that you're looking for from established businesses that can help you grow this initiative?
Yeah, we need maybe electrical engineering, mechanical engineering, systems engineering, controls engineering. We need material science, we need microfluidics, we need computer modeling. We need every kind of engineering you could possibly imagine, except maybe civil engineering. None of my engineers are civil, and it's been working. No, we even, by the way, need civil. We need to figure out, most of these organs are going to have about a 4 or 6 or an 8-hour shelf life once they're made. They're grown, they're living. We're literally, whether it's drones or other means, we're going to literally have to figure out how to build an infrastructure for physically delivering these things, to get them into the sterile field, to give them to the physicians. The exciting thing here is, we need every engineering discipline you can imagine, as well as the basic sciences, as well as regulatory policy. We're working now with the University of New Hampshire. They're making courses even on the bioethics of this. How are you going to decide who gets what and when and why? And by the way, how are you going to figure out cost? Think about that. Let's say somebody needs a kidney or a liver, and that might cost $50,000 or $100,000 by the time you figure out what it costs to do. Then you say, yeah, but don't you understand if you don't give them that kidney, the cost of dialyzing them every other night costs $150,000 every year for the rest of their life. It's $100 billion a year to keep chronically treating people that you don't cure. Yeah, but the insurance company doesn't have to pay the whole amount right up front for that situation. And the way our healthcare system works, they don't want to, because that's another whole long story. We always put the pea under the next shell. If this industry is going to come about, we need not just the curriculum for the engineers, we need the curriculum for the business school, the law school. We need policymakers to help make sure that we find the most effective way to get these solutions to the people that need them. Again, the long answer to your question, we need every creative engineering skill set you can imagine. And to do some of this stuff, sadly, we need a few skill sets that we can't imagine yet. We need some invention here. But we'll create it.
Okay, so with that, we're coming down to the close so that we can open up the reception again. And I believe you guys will be around for people to talk to. So if you have other questions that didn't get answered, please feel free to, chat with these guys directly and continue the conversation. So I'm not going to spend time trying to get the slide deck back up. I'm just going to kind of close things out a little bit here with just thanking again all of our sponsors. And I'd like to just ask Christina Ferrari to come up from Bernstein Sure, because Bernstein was our platinum sponsor for this event. And she'll close us out and welcome us to the reception. So Christina?
Thank you. Good evening. I realize that a lawyer is keeping you all from the reception, so I apologize. I'll make this very, very quick. I want to let you know that Bernstein Sure is incredibly proud to sponsor this event. As a member of the High Tech Council, we've been planning something like this for well over a year, and to see it come to fruition tonight and have you all here is just incredibly special. If you don't know who we are, we're a full-service law firm actually located just down the street in this incredible mill yard. And I echo Governor Sununu. If you have any hesitation at all, you should throw it out the window, pack your bags, and move here, because it's an incredible place to work. It is special, and I highly, highly recommend it. We've been located here for almost 20 years, and we counsel biotech, med device, and pharmaceutical clients on every step, from laboratory bench to the marketplace. And to see an emerging biotech system here on our doorstep is something that just wasn't even imagined 20 years ago. And I applaud the work that ARMI and BioFab USA is doing, along with all of its collaborators and supporters. If you haven't joined ARMI yet, if you haven't joined the New Hampshire High Tech Council yet, please, please do so, because without your support, this ecosystem isn't going to get off the ground like it needs to. And it matters to every single one of us, regardless of what discipline you come from, what industry you come from. It won't succeed without complete buy-in from all of us. We have a few things that are coming up with the New Hampshire High Tech Council that I want you to be aware of. And again, if you haven't joined, please do so, because we're trying to really get our community here in New Hampshire up and running and be vibrant. And so we have an event coming up in May 15th, I believe, and we're talking about workforce development, which is something that all of us care about here. You've heard a little bit about what that means from Dean, and it's an event that we hope that you'll join us with. We also are going to be at Bio in Boston in June, and there's actually a whole booth from New Hampshire that's going to be there, so please join that as well. And these are all on our website, hampshirehightechcouncil.org, so please join us. With that, there's a reception right behind us and our exhibitor booth, so please head to that area, have a cocktail, have some snacks, and we thank you for coming. We hope to see you soon.